Hey guys, today we're going to finish looking at the sun's path across the sky by looking at the day and night cycles. And then we're also going to talk about a little bit more about constellations today. But here, what you can see here, we can see that here this is a very special place. The circle of stones that we see here, this is called Stonehenge. We've talked about this before. So more than 4,000 years ago, human beings stood on this spot to observe the heavens. So this is a pretty ideal place to begin our study of astronomy and constellations with the sun's path across the sky. So this window is showing you right here, you can see the sun, and you can see right here it says west, southwest, and then this is northwest. So up here we have the time, and what I can do is I can press play, and we have this set so that the sun's gonna, the flow rate 1 second equals 1 minute. So as the sun is moving across, every 1 second is 1 minute. The sky is moving. The sun is moving across the sky. So let's see what happens as we press play here. So what you should see, and we do see it, is that we see the sun slowly sinking across the sky in the west here. Hopefully you can see that. So it's sinking in the west, and as it's going to dip below the horizon here, the dark sky happens, and then you're going to see the brighter stars begin to appear. And so with the passage of time here, we can see how the time is passing right up here. So with the passing of that time, this darkness eventually is going to be lifted again as the sun is going to rise across the sky. And then it's going to pass above the sky in the east. So I can go to east here. And there you can see the sun. It's above the horizon now, which is beginning a new day. So in this exercise we're going to do with this program I have, we're going to learn about the motion of the Earth that causes the daily cycle of night and day as we go. Okay, so let's observe the daily cycle of the sun. And now we're in a place where you might find modern sky gazers. This is Central Park, New York City. So this is a spring morning just after sunrise. And I want you to try to answer a few questions for me from this view. First thing I want you to see is that besides the sun, what other objects are visible in the sky? So in just a minute, I'm going to show you, but just take a look and see if you can see other objects in the sky in this, this image here. Okay, in order to see it, here's a little hint for you. Look to the right of the sun. So there should be at least 2 objects you see. Even though it's daytime, you can still see these objects. So look carefully. In just a second, I'll put the mouse on them and you can actually see what they are. And then next, what I'm going to do is I'm going to press play here, and we're going to see how the sun is going to move across the sky. And I'm going to move the screen with the sky so that you can see where it's rising and where it's setting and what happens after this happens. So I want you to just observe a couple things. First thing I want you to do is just describe the motion of the sun as it travels across the sky after we identify these objects that you can see in the sky besides the sun. So right here to the east, so we can see the sun there. Looks like it's rising in the east, and looks like it's due east. And so if we look to the right, first thing we see, you should be able to see this object right over here. And I can actually click on it, and you can see up on the right-hand side of the screen, up on the left-hand side of the screen, it says the moon. So this shows you, you can see the moon during the day. So the moon is there. Now it looks like the moon is about to be a new moon. You can only see a little slither of it right here. So this is a waning crescent. And then if we look below that, a little bit to the left, you see this object right here. So there's the planet Venus. So Venus is actually a morning and evening, it's called the morning and evening star because you can only see it in the morning right before sunrise or right after sunset. So just as the sun's rising here, we can still see Venus just a little bit. And then if I keep going down just a little bit, keep going down to the left here. Let's see if we can find it. Mercury is going to be right over here as well. Somewhere right over here. It's not showing up at the moment, but we have Venus, Moon, and then Mercury is going to be over here. So let's press play. And let's observe what happens to the sun as we go. So we're still looking at 1 second equaling 1 minute. So notice which way the sun moves as we press play here. So notice which directions it's heading. So it looks like it's going higher in the sky. And notice, so there's east, and now we're facing south. There's the sun. It's moving across. Now it's getting lower in the sky. And then look where it's going down at. So it goes down in the west there. So notice how it arced across the sky. So where did it rise and where did it set? And now we can go back to the other side and see what happens on the next day. So we can see the nighttime sky, we can see all the stars and constellations out. And then notice the time here. So let's stop right there. So it's about 6:30 a.m. And if we look here, let's see what this object is right here. This says Venus. So we can see Venus right here. And we're not going to be able to see the moon because now it's a new moon, but the moon will be out as well. And then somewhere over here would be Mercury again. So what you should notice from the slide, hopefully you can see this pattern here, is that the sun is always rising over here in the east, and it's always going to set in the west, and it's always going to arc across the sky in the south. The sun always arcs across the sky from east, going across the sky in the south to west. And you'll see that the planets, they also follow this line. All the planets kind of move along this path the sun takes. Hopefully you remember what the path that sun takes is called. That's called the ecliptic. So let's watch this one more time just to see if we're right, if it's going to continue that path. So there's the sun going across the sky, starting in the east, arcing across in the south, which is why we're going towards the south now. There's the south. We look up, there's the sun, and then it's going to start coming down in the western part of the sky. And then it sets in the west. And then we can see nighttime starting. Look, there's a Orion, constellation Orion right there that I'm grabbing. Hopefully you can see that. That's going to be one of the winter constellations we talk about. So I'll talk about some constellations in just a little bit. I'll show you the circumpolar constellations. And then we're going to talk more about, we already talked about Ursa Major and Ursa Minor. We're going to talk about Draco, Cepheus, and Cassiopeia coming up. So hopefully you can see this pattern repeating itself once every 24 hours. So in general, you're going to have, depending on the season, around 12 hours of sunlight, 12 hours of nighttime, but it's going to change depending on what the season is. Sometimes you're going to have more sunlight. Other times you're going to have more nighttime. It depends on if it's summer or winter. So we'll talk about that as well. So, but just so you can see the pattern again, there's Venus, there's the sun, and again, moving across the sky in the east, and it's going to set in the west, always arcing across the sky. Hopefully you know this by now, in the south. So now you can see it's dark, so we're in the same location. So we're still in Central Park, and we can see the stars out at night. And right now we're facing east. So what I want you to do now is I just want you to spend a minute and just watch the motion of the stars. So we just watched the motion of the sun. Now let's watch the motion of the stars. So I'm going to press play here and just notice how they move. So hopefully you can see what's going on over here in the east. So what are the stars doing? Are they moving up? Are they moving down? Are they moving across? So hopefully you can see it looks over here that they are moving up, and we call that rising. And then we can follow those stars. So let's move our view to south, to the southern part of the sky, and we can see how they're moving. And then we can continue on, and we can move over to the western part of the sky, and we can see what's going on over here. So over here in the west, hopefully you can see these stars. What are they doing? Are they going up? Are they going down? Are they going across? Looks like they are definitely going down, so we're calling that setting. They're going below the horizon. So this right here, this is the horizon. So where the land and sky meet, that's called the horizon. So we can see the stars are going below the horizon in the west. They're setting just like the sun rose in the east and set in the west. All these stars are also rising in the east and setting in the west. So let's go back to the eastern part of the sky. And now I want you to look for, we're going to look at the moon and Venus again. Let's see if we can find the moon and Venus. So let me go back for a second here. Okay, so right there in the east. So right here, this is the sun. And I told you what's always near the sun. Hopefully you remember from just a minute ago that we said Venus is always near the sun. So over here, this would be Venus. There's Venus. So we're going to track Venus's motion across the sky. So let me go back and let's get it a little lower. So right there. Okay, so let's move forward now. So it looks like Venus is right above the horizon. And so let's track Venus's motion across the sky. So it looks like it rose in the east. It's moving across the sky in the south, arcing higher in the sky. And now we're facing over in the western part of the sky. We can see Venus right here, and then it sets below the horizon in the west, just like the sun is about to set in the west. So let me stop it there. Let's go back to the east. And I want you to observe the motion of one more object. So now I want you to observe the motion of the moon. So let's find the moon, and we'll observe its motion. So we got to wait for the moon to come out. There's the sun. And there's the moon. So there's the moon. It looks like it rose over here, eastern part of the sky, just like the stars did, just like Venus did, just like our sun did. Rose over here in the east. Let's continue to watch and see where it's going to go up in the sky at. So it looks like it's getting higher in the sky towards the southern part of the sky. Continuing to move towards the west. So let's go down towards the west and see what happens in the western part of the sky. So now the moon is setting over here in the west. So hopefully you've seen that, you realize that, you know that all the objects in the sky are rising in the east and they're all setting in the west, and they're all arcing across the sky in the south. So that's the motion of the moon. It's the motion of all the stars, including the sun. It's the motion of the planets. They're all going to rise in the east, set in the west, arc across the sky in the south. The only ones that are going to move a little differently are the circumpolar constellations. And again, we'll talk about those in just a little bit. All right. The motion you have observed in those previous slides I showed you here in this program, that motion is called diurnal motion. Diurnal motion. It is shared by every object in the sky, and it repeats daily. So that's what you've just seen. But here's the question. What causes this motion? What causes this diurnal motion? So diurnal means that there's two motions involved. So in this window here of the screen here, now you're seeing the Earth as viewed from space. Now it's 6:30 a.m. on July 10th. So please just notice a couple of things about this. So the first thing I want you to notice is, and I know it's 6:30 because it says so right here. So 6:30 a.m. July 10th. That's what time it is here where we live. So my first question to you is, why is part of the Earth dark? So if you look at the Earth here, you should see that part of it's dark and part of it's not. Part of it over here has light. So think about why that is. And so what I'm going to do is I'm going to click run here, and I just want you to observe the motion here of and what's happening on the Earth. So let me press play, and then watch to see what happens. And we'll talk about it after. So hopefully you see that the Earth is doing something after I press play. And over here you can see the time, and just observe and watch what happens. And what I'm going to do is I'm going to stop it in just a minute. Okay, so what just happened? Hopefully you guys can understand what just happened. So when I clicked run, you could see the Earth doing what? Hopefully you notice that the Earth was actually rotating. And as the Earth rotated, hopefully you noticed that different parts of the Earth were lit up on this side, and then different parts of the Earth were dark on this side. Now, approximately how long did it take for the Earth to make one complete rotation? Did anyone notice that? So if you look over here, it's 6:35 a.m. now. So I'm going to press play one more time and just notice what happens here. So we said right here, this is where we live. So Atlanta, watch what happens when we press play. So there you can see the U.S. going by. And we're going to wait for it to come back to where it started. Oop, too far. Okay, so right here, this is where the U.S. is about to start having sunlight. So how long did that take for the U.S. to go through a complete rotation? Hopefully you notice that it took 24 hours. So from 6:30 a.m. to 6:30 a.m. the next day, that's how long it took for the Earth to get back to its original location. So hopefully you can see that it takes 24 hours. That's the day and night cycle, 24 hours. That's how long it takes for the Earth to go through a complete cycle of day and night. Okay, so next question I want you to answer here. In which direction must the sun be located? So where's the sun at? Is the sun going to be over here, or is the sun going to be over here? Hopefully you can realize where it's at. So let me press play. And you can see that over here, this is daytime, which means where does the sun have to be? Hopefully you realize that it's going to be somewhere over here, to the right of the screen. Now, does the Earth give off its own light, or is it only getting sunlight? Well, hopefully you can see that here's the Earth. And what I'm going to do here, I'm going to show you. We're going to zoom out here, and we're going to see where the sun is. Okay, so this is a zoomed out version. And there you can see the Earth. And then over here to the right, there's the sun. So the Earth does not give off its own light. It only gets light from the sun. So all that light we saw on the Earth, on the right-hand side, that was from the sun, which means on the left-hand side of the Earth, that was nighttime. Okay, so now we've changed locations. So now we've moved to the North Pole on a very cold January morning. And what I want you to do now is I just want you to observe the diurnal motion from here at the North Pole. So please notice, how are the stars moving? So why are they moving this way? Hopefully you can see how they're moving. What I'm going to do is I'm going to put on a celestial grid here, and that might help you see the motion. So we see there's the grid, and we're going to go over here to the east. Okay, and notice, do you see any stars rising, or any of the stars rising over here? To me, it doesn't look like they're rising at all. What does it look like they're doing? Does it look like they're going higher in the sky? It doesn't look like any of them are arcing across the sky higher either. And then if we go to the west, remember what's supposed to happen in the west? Stars are supposed to set in the west. So let's see if they're setting. So over here in the west, there's nothing setting either. So the diurnal motion here at the North Pole is going to be a little different, way different actually. Instead of stars rising and setting, you're actually going to see all the stars and constellations in the sky they're going to be rotating around what? Hopefully you remember what they're rotating around. So what we can do is I can look at the very tippy top at our zenith, and hopefully you can recognize what's up there at our zenith. So right up here, you should see Polaris. So I know it's Polaris because I can look to the top left of the screen and it says Polaris. So this constellation up here, this is Ursa Minor. So there's Ursa Minor right here. We talked about that one already. So that is the Little Dipper, the Little Bear. And then right over here, we can see Ursa Major. There's the Big Dipper or the Big Bear. We talked about the names of all of these stars. And then we talked about Meroc and Dubhe here and how they're pointer stars pointing to Polaris. And then I also mentioned the names of these other ones, Alioth, Alcade, and all of them. And then Mizar and Alcor, which would be right here, the binary star system. Right there. So it's just kind of interesting. This would be a very cool viewpoint from the North Pole. I would love to see the sky like this at some point. Unfortunately, in order to see this, you'd have to go up to the North Pole during the wintertime. Now, hopefully you're noticing something else as well. So look at the time go by here. So it's about to be 8 a.m. and now it's 9 a.m. and it's 10 a.m. and it's still dark. So why is it dark all day long at the North Pole? So during the wintertime, it is dark all day long, nonstop, 24 hours a day. It is dark. Why would it be dark so long? What would have to be missing? Hopefully you can realize and understand and see that no sunlight is actually making its way to the North Pole during the wintertime, which is why it's dark constantly, which is why it gets so cold as well. One of the reasons it gets so cold. That has to deal with how the sunlight is bouncing off of the Earth. And we're going to talk about that. It deals with the Earth's tilt. So the Earth is tilted 23.5 degrees, and that tilt is what causes the seasons of the Earth. It has nothing to do with where the Earth is located as it revolves around the sun. It's all about the tilt of the Earth. Okay, the last thing I want to show you for today is just those circumpolar constellations. So again, circumpolar means they are circling around the pole, which is Polaris right here. We talked about Ursa Major right here with Ursa Minor. And so there's 3 more constellations. I'm just going to show you where they are today, and then I'm going to actually tell you the stories behind them and talk about the stars in them tomorrow. But just for references, and I'm going to show you where they are without the outlines, and then I'll show you them with the outlines or illustrations of the constellations. But here we have the Big Dipper. It's the easiest of the circumpolar constellations to find. We have Meroc and Dubhe, and they are the pointer stars pointing to Polaris. So Polaris is at our zenith right now because we are, again, at the North Pole. There's the Little Dipper right there. So the Big Dipper is going this way. Remember, the Big Bear is running around the sky this way, trying to get to the Little Bear. Little Bear is running this way, trying to get to the Big Bear, and they can never quite reach each other to give each other hugs. We talked about why that was. Another constellation, one of the circumpolar constellations, is actually between the Big Dipper here and the Little Dipper. And the way you find it is you look for the star Dubhe right here, and the next star over, this is actually the tail star of Draco the Dragon. And so Draco the Dragon, it looks kind of like to me it looks more like a snake than a dragon, but it's a dragon. It's supposed to be a dragon with a broken back, and we'll talk about why that is. And all it does is it curves between the Big Dipper and Little Dipper. So again, there's the Big Dipper right here. Here's the Little Dipper. And it's going to curve between these 2 constellations. And then it's going to actually curve underneath the Little Dipper here until its back breaks, and then it goes in a straight line and you look for its triangle head. So it has a triangle head. So we start here with the tail star, and then we just connect these dots, these stars, the brighter stars. Hope you can see that these are brighter. And we connect these dots, keep going, and like this. And then this is where the back breaks. So where the back breaks, we start going in a completely different direction. So we're going to go down right here like this. So we started, there's Dubhe right there, there's the tail star. We come like this, curve underneath the Little Dipper, which is right here. We curve under the Little Dipper. We get to the back breaking right here, curve, go in a different direction, continue right here, and then we find the triangle head. So we go in a straight shot till we find the triangle head, and this is the triangle head of Draco right here. So that's the head of Draco, and we just curve like this. Hopefully you can see that. It does take practice. I really don't expect you to see this right now, but if you do go outside and start looking for these constellations, you'll start finding them. It'll be easier and easier and easier the more you practice. So I'll tell you about some of the stars, particularly just one star in Draco is really all we need to know about, and I'll tell you about that one tomorrow. But again, the way you find it, there's the Big Dipper, there's the Little Dipper. Between the two of them, next to the star W, is the tail star. You go down between the two of them, you curve underneath the Little Dipper. There's the back break, and we go to the triangle head. So that's Draco. Now, the way we find the other two, they're always on the opposite side of the Little Dipper here than what the Big Dipper is. So here, there's the Little Dipper, there's the Big Dipper. So if the Big Dipper is over here beneath the Little Dipper, the last two constellations are going to be above the Little Dipper, so somewhere over here. So let's just move this along until we can see it. And so there we can see one of them. I'm going to make it so that we can see right here. So there's the Big Dipper. There's the Little Dipper right there. If the Big Dipper is to the right here, the next constellation we should be able to see is called Cassiopeia or Cassiopeia. I'll tell you the story about her tomorrow. She's going to be over here to the left. So there's Cassiopeia right here. So Cassiopeia, to me, she looks like a W, a sideways W or a sideways M. So there's 5 really bright stars in Cassiopeia. So hopefully you can see those. So again, Big Dipper is over here on the right. There's Polaris, which means Cassiopeia has to be to the left. So there's 1 star, 2 stars, 3, 4, and 5. That's Cassiopeia right there. And there's more stars that make her up, but I'll talk about them later, tomorrow, not today. The last constellation that we're going to learn about tomorrow is Cassiopeia's husband. His name is Cepheus, and Cepheus is always going to be right near Cassiopeia. So in this location, if we have the Big Dipper over here on the right, the Little Dipper in the center, Cassiopeia to the left, Cepheus is going to be right down here below Cassiopeia. So there's Cassiopeia. Here's Cepheus. So Cepheus looks like a house that you draw when you're in kindergarten. 5 stars, 5 bright stars, make them up. You have, think about a house you draw in kindergarten. You basically have a square house right here, square house, 1 star, 2 stars, 3 stars, 4 stars, and then you'd have a triangle roof. So that star right there goes to the triangle roof. So that is Cepheus right here. So there's Cepheus. Here's Cassiopeia, Ursa Minor, Little Dipper, Ursa Major, Big Dipper, and then there's the tail star of Draco, and Draco comes like this. And then the triangle head's going to be down here, right there. So those are the 5 circumpolar constellations we're going to need to know about, and I'm going to review all these tomorrow. But for today, I just wanted to show you those, and then I also just want to show you what they look like. So I can come over here to view, and we're going to go to constellations, and I'm going to show you the illustrations of them, just so you can see I'm not making this up. So there's the Big Dipper, Ursa Major, Meroc and W, point over to Polaris right here, which is the tail of the Little Bear. Between the two of them, you got Draco. He curves beneath the Big Bear. Beneath the Little Bear, and then his back breaks, and then you got his triangle head right here. And we said if Ursa Major is to the right, Ursa Minor is in the center. Over here to the left, you got Cassiopeia, which is a W, right over here. Starts there, and then it goes like this. And then right below Cassiopeia is her husband, Cepheus, and he looks like a triangle house. So 1 star, 2 star, 3 stars, 4 stars, and then there's the 5th star, which makes right there. There's the 5th star, which makes the house. He's not a house, he's actually a person, and we'll talk about who he is again tomorrow. But I just wanted to show you those illustrations. So those are the circumpolar constellations. I did mention this one to you as well. We said some people consider Camelopardalis, the giraffe, to be a circumpolar constellation as well, but you will not see that on my test. And then I can press play and just show you how they move, and we'll speed it up. And you can see all of those constellations orbiting around Polaris right there. And you can see the diurnal motion from here in the northern part of the sky at the North Pole. The diurnal motion is that all the stars are rotating around you, basically. If you're standing on the North Pole, you can see all these constellations rotating around you. None of them are going to rise, and none of them are going to set. It would be a very beautiful thing to see in the night sky. So that's going to do it for today. Tomorrow, we'll talk about the stories behind those constellations, and I'll go over the star names you need to know. Thanks, guys.